Welcome to our channel for probability and statistics. In this video, we will talk about the mean and variance of the estimators in linear regression. So we know linear regression is just a linear model used to find some inherent linear relationship among variables. So this is a simple linear regression model because there's only one x. Here x is the regressor or independent variable. And this is multiple linear regression because there are two independent variables, x1 and x2 here. So for the simple linear regression, we can use a straight line in the two-dimensional space to depict the relationship between x and y. So this is the beta 0 parameter for the intercept, and beta 1 is the slope of this line. And the estimation of the linear regression model is based on the idea that we will minimize the sum of the squares of this E1, which is the error between the observations xi, yi, and this fitted line. So y hat is the beta is b0 plus b1x. So b0 is just the estimation of the beta 0. Because beta 0 plus beta 1x is the real line, but we never know this parameter. We only can estimate using b0 and b1 here. So this line is called fitted line or linear regression line. So the estimation of the linear regression is based on the least squares, which will minimize the sum of squares of this error. So the parameter or the point estimate of b0 and b1 is b0 is the y bar, the average of all y value minus average of x value times b1, and b1 is the sigma of the cross product of xi and yi with respect to their corresponding mean value, then divided by the sum of squares of the xi with respect to the corresponding x bar's value. And we know it's very important that the values of b0 and b1 is random value, because this is just based on a given sample of n observations. So they are only estimates of the two parameters beta 0 and beta 1. So if we repeat the experiment again, we may not get the same value of b0 and b1. So which means b0 and b1 are the coefficients and estimates of the coefficients, or say the estimators, they are random value. They both are random value. Because if we look at the formula again, you can see the b1, b0 based on the value of x and y, right? But here x a deterministic value. X are not a random value. Only y a random value. Yi, y bar, both are random value from sample to sample. So the y value, sigma y value are random value. Y value. So y value has a variance. So variance of y given xi equals sigma square. So this sigma square actually is the error term's variance. if we look back again, yi equals this fixed term plus an error term. And this error term is the counterpart of theoretically error term if 0. So this EI has, we assume this has independent, identically distributed random variable, and its variance is fixed for different values of x. So this error term has a variance sigma square. That's why the y value also has the variance of sigma square, right? So after little complicated mathematical manipulation, we can get the mean of the parameter beta 1 is the actual real value of beta 1, and the mean of and the variance of the b1, this estimator, also estimate, and the variance of the estimator b1 is this term, is the variance of the linear regression module, or the variance of the error term divided by the sum of the squares of xi with respect to x mean value. And mean value of the estimate b0 equals the real value of the beta 0. And the variance of the b0 equals error terms variance times sigma square of xi divided by n times the sigma squares of xi with respect to the x mean value. So it's very interesting. If the sum of squares xi with respect to x bar will be bigger, then the variance of bi will be smaller, right? For the same variance of error term. So this means, if we look back to the linear regression line, what this means? Because if we have the observations for the x and the y, if with x is a very small region, for example, starting value x here, ending value x there, so we only know x, y value between this range. So the variance of this slope b1 will be larger. But if we get x value very large, for example, starting value x here, ending value x there, so we get the range of xy in this whole range almost, then we get the very small variance of b1. So this is just like physics. If we get the very small range of x, this straight line like it's not very stable, right? It might shake from here, from there, not stable if we do many times of estimation. But if we every time get x range very large, then this straight line will be stable and get a small variance for this slope, right? Because we are very interested in this slope more than this intercept, and this slope determines the relationship between x and y. Thanks for watching.